Hello, welcome back. This is the start of second semester. I'd like to say hello to all the noobs in Mr. Begeiski's honors geometry class. So welcome. Let's enjoy the rest of this semester. We're going to be starting with 7.3. We're going to be looking at formulas involving polygons. So in a sense, we're going to be finding the sum of the interior polygons, the sum of the exterior, and actually the number of diagonals. So when we look at this, let's jump right into the chart. We look at it and say, okay, a figure has to have three sides, first off. So one, two sides doesn't exist. So we have three sides. A three side, how many triangles can you make? You can make one triangle out of there. Okay. The sum of the interior. Well, everybody should know that. We learned that in 7.1, which we did first semester, is 180 degrees. The sum of the exterior, on the other hand, you have to figure out, from a triangle, in a sense with the three sides, how much does all three of the exterior angles have to add to equal? I'll give you that one. That's 360. Okay. And then lastly, the number of diagonals. How many diagonals can you go? A diagonal goes from one vertex across to a different vertex. Well, this can't be a side, so we have 0 diagonals because I can't figure out a way to draw them in there. We're going to finish the chart and see what we come up with. If you have a four-sided figure, now you're at a quadrilateral. So a four-sided figure of what we're looking at, and we're saying how many triangles can we have? Well, when we draw one of the diagonals, then you have two triangles. Okay. Well, now using that idea, what do you think the sum of the interiors? Well, if I have two triangles, let's think about it. Oh, well, 180 plus another 180, booyah, 360. Sum of the exterior. So let's take each of the four exterior angles and see how much they add up to. Well, if you think about a square, each interior angle of a square is 90 degrees. So each exterior angle to the square would also be 90 degrees, and there's four of them. Well, 4 at 90 apiece gives you an answer of, you guessed it, 360. And then lastly, they want the number of diagonals. Well, diagonals can't cross, you can't overdo the number of diagonals that you have. So when you look at it and you say, okay, the number of diagonals, there's one diagonal, there's the second diagonal, and you can't go back the opposite way. So how many does it have? It has two diagonals. Okay. Continuing, five-sided figure, that's a pentagon. It's a building in Washington, D.C., if you did not know that. So that means if you draw in 1, 2 diagonals, you can make 1, 2, 3 triangles. Using our same idea, well, there's 3 triangles at 180 apiece. We're at 540. And let's take a guess. If you took all the 5 exterior angles and you added them together, do you start seeing a pattern here? Well, guessing 360 would be a great idea. Okay. Now you have to figure out the number of diagonals. Well, we had 2 above, so it's obviously got to be more than 2. Well, you have 1, 2 coming out of this vertex. Over here, we got 3, 4 coming out of that vertex. This one already has this one. There's the 5th one, and then you're back around. So how many does that have? That has 5. Okay. 6-sided figure as we continue. Number of triangles. Do you notice a pattern yet? Let's go with 4. What's the sum of the interior? You haven't seen the pattern. 720. That's what it is. 360. Number of diagonals. Take a guess. 9 will be your answer. Okay. Dot, dot, dot. Now we're skipping all the way down to 10. Well, can you see a pattern? Well, let's look at it. Okay. Well, what's the difference between 6 and 4? What do you notice? It's 2 less. So if this is 10, how many do you think the number of triangles would make? It would make 8. Thinking of the pattern, if it makes 8 triangles at 180 apiece, right, what are you ending up with? 1440. Sum of the exterior, 360. Number of triangles, the number of diagonals you can make ends up equaling 35, and you will notice that there is a pattern that comes into play here. So let's just talk about it. Pattern here, what's happening? You add a side, you're adding 180 degrees, and that's what just keeps happening. Here, what happens? You add a side, it stays the same. Here, what do you notice? All right, 0 diagonals, so this goes to 2. Here, what's the difference? 3. So 2 and 3 make 5. Here, the next difference has to be 4. 5 and 4 make 9, and so on. 5 would have to be the next difference. So a 7-sided figure would have to have 9 and 5 added together. So what do you add? You add 14. So you can see that there's a pattern also going through there. So now let's talk about the theorems that you will have to have memorized. I said will have to have memorized for the test and for the rest of the semester. Theorem 55 is the sum of the interior. So that's the column with the 180, 365, 47, 20, and so on. The sum of the interior is this, is the measure of the angle of a polygon with n sides is given by the formula. Sum of the interior equals n minus 2 times 180, which totally should make sense to you due to the fact that what do we have? This is n. This is n minus 2, right? Because 8 is n minus 2. Gives you the 8. So we get the n minus 2, and then what did we do? Over here, we took 8, and we times it by 180, and that gave us the 1440. We took 4 times the 180, and that gave us the 720. So here's the formula you have to memorize to be able to do the sum of the interior. Sum of the interior is n minus 2 times 180. Well, sum of the exterior here is easy. Sum of the exterior equals 360. If one exterior angle is taken at each vertex, the sum of the exterior of the measure of the exterior angles of a polygon is 360 degrees. That's a nice one to memorize because all of them end up being 360. And lastly, when we want to count the number of diagonals, right, so what do? The number of diagonals drawn with the n sides is this. Diagonals equals n times n minus 3 divided by 2. Okay, so you're taking n minus 3. So it's different. Watch it. The diagonals is n minus 3. The sum of the interior is n minus 2. You're dividing by 2. Well, why are you dividing by 2? Because we talked about, you know, when you're counting a figure, so here's 1, here's 2. I can't count this backwards as 3 and then 4. No, you're writing on the same line. So there's only 2. So you're dividing by half because you can't count both ways, you know, for your total. So that's where your dividing by 2 needs to happen. Okay? So the diagonal is n times n minus 3 over 2, which completely makes sense because let's say if you were doing it here and you did 10 times 10 minus 3 over 2, well that's 10 times 7 over 2. Well, 10 times 7 is 70 over 2, what ends up equaling that 35. And we're done. Ta-da! Knowing those three, like I said, you should be great for this this unit, for the unit test, which is coming up pretty soon. So let's look at this. First off, we look at it. We want this angle on the exterior right here. So if we need to get the interior angle first, so then we can get its supplement on the outside. Hopefully that makes sense because these are supplementary. I'll write it down step by step. Well, first off, we see this as a 1, 2, 3, 4, 5-sided figure. 5-sided figure, so we got n is equaling 5. So first off, we got 1, 2, 3, 4 sum of the interior angles. So we need to figure out what the fifth one is. Well, right now we can add all of these up. So if I add up the 90 plus the 120 plus the 160 plus the 150, I get a total of 520. Well, we learned that 5-sided figure is n minus 2 times 180. Well, the sum of the interior for this is 3 times 180, which ends up equaling 540. Well, if the total needs to be 540, but what we have is 520, what do? We subtract these two, 540 minus 520, and we get 20 left over. So this interior angle ends up being 20. Not what we wanted. We wanted supplement on the outside. So we do 180 minus 20. And the angle we are looking for on the outside, the missing angle, is equal to 160 degrees. Lock it in. You're golden. Example number 2. How many sides does a polygon have if the sum of the interior is 2340? So now we're working our way backwards. So instead of giving us the n, they're giving us the total. Well, we still know they're giving us the sum of the interior, so you have to use the sum of the interior formula. That's the only thing that would make sense. Well, what do you do? So this is the sum of the interior. So we're going to put 2340 equaling to n minus 2 times 180. Right? And now we're solving for n. Well, most of you would like to do would probably be distributing the 180 and then doing it. Get rid of that idea. Let's do it algebraically. Divide by the 180 first. When you do that, what happens is then it simplifies it that this side is n minus 2. Over here, you're going to take 2340 divided by 180, and you end up with 13. N is still not by itself. Add the 2 over, so n ends up equaling 15. You could then try it out and say, okay, 15 minus 2 times 180. What do you get when you do that? 2340. And you are done. B, same idea, but in this case, we're going to set 1450 equal to n minus 2 times 180. Do the same thing, divide by the 180. You get n minus 2 is now equal to 8.055 repeated. And add a 2 over. And what you get, n is equal to 10.055 repeated. Wait a second. Can you have a figure that has 10.055 sides? Not in my world you can't. It would be like an extremely missing side. You know, you'd have this much more of the fencing that you'd have around something. Come on. So anytime you have a decimal for n, you know, is impossible. Okay, so you get impossible if you'd get n being a decimal. Good. Hopefully, last one. Let's finish it up here. We're right at about 12 minutes. Example 3. What kind of polygon has 45 diagonals? Okay. Well, once again, we know what formula we're going to be using. This time we're using diagonal equals n times n minus 3 over 2. So what we need to do, we need to get the number of sides, but we have the number of diagonals 54. Don't put it in as n. It didn't say it's n. It says it has 54 diagonals. We want the number of diagonals. So 54 is equal to n times n minus 3 over 2. Well, first off, we want to get rid of that over 2, so we're going to multiply both sides by 2. That gets rid of it. Don't double the top. This side is 108. At the same time, what do we have here? We can distribute the n, giving me n squared minus 3n. Oh, you probably figured by now that you see an n squared. So what do you have to do? Louder. One more time. Factor. Good. Set it equal to 0. N squared minus 3n minus 108 is now equal to 0, and we're able to factor. It's always going to have a leading coefficient of 1, so this is great. So you know you can just go n and n. You need two numbers that multiply to negative 108, but add to negative 3. Being able to do that when you look at it and you distribute, what do you get? You get positive 9 and you get negative 12. That gives you the negative 3. So your two answers are negative 9, boom, and positive 12, boom. Wait a second. How can a figure have negative 9 sides? We're not talking about a black hole here. So we'll get rid of the negative 9. So we have 12. It's a 12-sided figure. It says what kind? Well, that means you have to name the figure. And if you don't know what a 12-sided figure is, it's a dodecagon. That takes us to the end, but I'm going to quickly give you the names for the figures if you do not know this. So a three-sided figure was a triangle. 3. 4, quadrilateral. 5, the pentagon. That's the X. Talked about it in MMA fighting. You got the octagon because it has 8 sides. We got the ocho, so it's got 8 sides again. 9, decagon. 10. Decagon. A decade is 10 years. 11. Name. 12. Do. Decagon. The do meaning the 12. And then 15 our book uses, which is the pentadecagon. So like an 11, you know, what do? You would just say something like, it's an 11, what you're going to do. All right, have a great evening. Welcome, and we'll see you.